Okay, so if you are in my math class, you've probably heard your students talk about the Big Seven or maybe the box method for division. And you're probably thinking, what on earth is the Big Seven? And so this is a new way that we're doing division. We cannot teach the standard algorithm just yet, even though I know that's what you guys are familiar with, what we all learned when we were in school, but it's a little bit different now. And so we're trying to teach our students how to identify the partial quotients of these larger problems. So I'm going to do a couple examples for you. This is what we call the Big Seven. Some students like the Big Seven. I feel like if your student is really good with mental math and knowing their basic facts, they will use the Big Seven well. If your student is still struggling to learn some of their math fluency facts, or maybe they don't line things up just right, you might want to stick with something else, not the Big Seven. But here's why we call it the Big Seven. We draw this gigantic 7 for our problem. And so we put our dividend inside just like we would do if we were just doing like a simple division problem. We're just going to extend it out to like a Big Seven. So let's do 585 divided by 5, okay? And so the first thing we're going to do with the Big Seven, we ask ourselves, can the divisor, the number outside, go into the first digit of the dividend? If it can, we're just going to kind of underline it here. And so if it can, then yes. How many times can 5 go into 5? Sometimes I ask my students, what times 5 gives me the product of 5? And so they will say, oh, well, the number 1 gives me that. Okay, so 5 times 1 equals 5. I like these visuals because it kind of gives us a flow, and we'll see that flow repeated as we go through this. All right, I can't just do this right here. I have to have something right here. So if I have digits, I tell my students, write zeros so that way we can have like a full subtraction problem. And this is kind of like a mirror. Whatever happens on this side of the mirror, I'm going to do on this side also. So if I have 2 zeros that I've added, I add 2 zeros here. Sorry, that looks kind of funky. I was looking at the camera and not the paper. All right, and now our problem is actually true. 5 times 100 is 500. So then I'm going to do a little basic subtraction. This gives me 85, okay? And so I can ask myself, 5 times what gives me 85? That might be hard for some kids. So we can break it down even further and kind of do the same thing we did up here. 5 times something is going to get me to 8 or really close to 8, all right? And so again, I can say 5 times 1, 5 times 1, well, that just gives me 5. Okay, I got to do a little more subtracting here. I have this digit, so again, I have a 0 here. Whatever I do on this side of the mirror, I do on this side. I have another 0 over here, okay? Because 5 times 10 actually gave me that 50, not just 5 times 1. I was actually writing 50 down here. And so now I'm going to subtract 85 and 50 and I get 35. Now this is a little more comfortable for a lot of our students. They can quickly tell you 5 times something gives me 35. What's that something? Those basic facts. 5 times 7 gives me 35. I know 5 times 7 gives me 35. I just want to double check myself, and yes, I have nothing left to work with. When I've hit 0, I do not have a remainder. We are talking about remainders, but in this problem, I don't have one. So my problem is done. I'm done with my dividing. Now these are called my partial quotients. If you watch the other videos about partial products, this is kind of the same standard here, partial quotients. I have 100, 10, and 7, and I just add those up. I get 117. So this is with the Big Seven with no remainder, okay? We're using the numbers that we can work with and making it kind of easier for us. We don't have to know all these big, huge facts or be skip counting up to crazy numbers like 85 or 585. We can make it smaller and kind of chunk it and then take those small chunks or those partial quotients to make our full quotient of 117.